we'll start 8.6 out with a little review of 8, I think 4, 8, whatever. Finding the product. So let's find the product of x plus 4 quantity squared. And remember we did this, we crossed off the 2, the squared, and just rewrote it twice. And then we FOILed, so first times first, x squared. First, outer, so 4x. Inners. And then last. And then here's my 2 inners, and we can combine them to get x squared plus 8x plus 16. Put me on pause and you do the second one and come back. You should have gotten x squared plus 10x plus 25, with the middle terms being 5x plus 5x. And then go ahead and do these two. So put me on pause and complete these two. So hopefully you got x squared minus 4x and then plus 4x minus 16, which would simplify after we combine our like terms to x squared minus 16. And then the second one, you should have gotten x squared minus 3x plus 3x minus 9, which simplifies to be x squared minus 9. I hope that you're noticing a pattern. So look at the two sets again. One is where we have a binomial squared, and one is where we have the difference of two binomials. So x plus 4, x minus 4, x plus 3, x minus 3. And there should be a pattern that emerges with both of these. So let's look at this. So we're talking about perfect squares here, and perfect squares are the product of a number and itself. So 1 is a perfect square because 1 times 1 is 1. 4 is a perfect square because 2 times itself, 2 is 4. 9, 16, 25, 36, 49, 64, 81, going on and on and on. These are all perfect squares. And we're hoping that you start to recognize perfect squares because oftentimes it can make your factoring faster. So to factor the sum of perfect squares, which would be like, for example, 4x squared plus 8x plus 1. So 4 is a perfect square, 1 is a perfect square. Each factor would be the square root of the first term added to the square root of the third term. So this would be the square root of our first term, which would be 2x squared, 2x, added to the square root of our third term, plus 1, and 2x plus 1, which we could write as 2x plus 1 quantity squared. So if we look at x squared plus 16x plus 64, pause and try to do it yourself. And hopefully you would have gotten the square root of x squared, which is x, plus the square root of 64, which is 8. And that would be two terms of that, which would be x plus 8 quantity squared. To factor the difference of perfect squares, so x squared minus 49, one factors the square root of the first term plus the square root of the third term, the other term. It would be the third term if we considered 0 x's in there, but it would be actually the square root of the first term and then the square root of the other term. And one would be plus and one would be minus. So this would factor into square root of x squared, which is x, minus 7, which is the square root of 49, and x plus 7. So in this case, square root of x squared, which is x, there's no middle terms, so I know I have to have opposite signs. So x minus something and x plus something. The square root of 16 is 4. So I should have x minus 4 and x plus 4. Here we have a number in front of x squared, but it's okay because it is a perfect square and another perfect square. We have no middle terms again, so I know we have to have two sets. One is a plus and one is a minus. Doesn't matter which way you write it, if you write the plus first or the minus first. Square root of 4x squared is 2x. And minus 64, so square root of 64 is 8. And we can double check, right, by doing this. That would be 4x squared. Here would be minus 16x in the middle, and here would be plus 16x. So those cancel each other out. And then at the end, we would have minus 64. I notice when the middle term disappears, or hopefully you notice when the middle term disappears, I need one of the factors to be plus and the other factor to be minus. Otherwise, those middle terms do not disappear. All right, you pause me, go ahead and give these a try. All right, here's what we should have. X plus 4 quantity squared for the first one, x plus 10 quantity squared for the second one, 2x minus 3, 2x plus 3, and again, you can have those in the opposite order for the third one, and 3x minus 5 and 3x plus 5 for the last one. And that is all for 8.6.